uh, this set of data, the number of hours that 9 students slept last night. And so we'll start with the mean and the standard deviation. So the average number of hours of sleep, what do you think it is roughly just by looking at the numbers?
9, 8.
Around 9, 8. Okay. So you've done this. This would be the easiest thing to do. And usually when people talk about the average, they mean this kind of average. But there's another kind. But usually they mean this. So let's just make sure we have to be complete, have it in your notes. You wouldn't need to show work when you're doing this in a book problem. But basically to find the mean, which is one way of saying the average, you add up the numbers and then you divide by the number of numbers. And you've been doing that for a while. And to save time, I already know that that's 8.8 minutes. And I know you can all do that, hours, and that's minutes. That would be bad. 8.8 hours average sleep. Okay, but now the question is how spread out is this data? So are most students sleep around 8.8 hours, or are there some that sleep like 1 hour and some that sleep 15 hours? And that would be really spread out. So we want to know on average what standard deviation says is on average, how much do these numbers, how far away are they from 8.8? And so just use your intuition, because it's always a good idea to make sure your answers make sense. How far away are these hours of sleep from 8.8 roughly? How many hours do you think away from? Just ballpark. So this is like 3. This is like 4 hours away. This one's like 4, but then there's a lot that are closer, right? So on average, what would the average roughly be?
2.
Okay, that's great. So about 2. So because it's easy to make mistakes on standard deviation, so you want to make sure that you have a ballpark. So this symbol is called sigma for standard deviation. And so what you do is you take the square root of this whole thing. So you take each number like 5, and to figure out how far away it is from the average, you subtract. And then I'll explain this notation. And then you take the difference and you square it. So you do that with each number, and then you add them together. It's kind of like taking the average. It's the average distance away from the average. And I'm just going to put plus ... because you do this for every single number. So I'll just do it for the last one. And that would be 12, right? How far away is 12 from 8.8? So you take each of those differences away from the average, you square them, you add them up, and then you are finding the average. So you still divide by 9, like we did with the mean. And then since you went through and squared everyone, your answer won't even make reasonable sense unless you take the square root of all of these differences. And so if you go ahead and do that, you would get, you guys were very close, 1.99 hours. So you might be asking, if we want to find the average distance from the average, why do we bother squaring and then taking the square root of all these, right? Yeah.
So the numbers aren't negative because like sometimes the difference.
Okay, so that's a good thought, like, because some of the differences will be negative, right? All the numbers below it will be negative, but we could still add them up and find the average distance. But if you don't square them, when you add all, do you know what you'll get if you add all these up without squaring them? Based on the definition of average, if you add up all the positive and negative numbers, what will you get? You'll just get 0. Yeah, and so that doesn't tell us how far away we are. So it's yes, we want to get all positive numbers. We want to square it so that and so that we don't get 0 every time. Yeah. So we get about 1.99 hours. Another way of measuring how spread out the numbers are is just finding the range. And you've probably done that before. You just take the largest data point minus the smallest data point. And so the range of hours is is 7 hours. Yeah. Okay, so that's a way of measuring center and spread. But then the problem with this is that if you have numbers like, let's say, average professional basketball players, like Kobe, right? He might make way more money than the rest of the players. So if you have a number that's really high or really low, it'll pull this average really high or really low. And then it doesn't give you a sense of kind of where the center is. And because those are called outliers, and they may be pulling things way higher or lower. So sometimes what's more valuable than the mean is the median, because the median is the number where half the numbers are above and half are below. So a really, really large number will only pull it up slightly. It won't completely pull it toward the extremes. So the median, you need the list to be ordered, which this is, and then you just look for the middle number. So we've got about 4 numbers here and 4 numbers here. So the middle number is the 5th one when we have 9 hours. So this is the median. What would you do if there's 2 numbers in the middle? You take the average. Yeah, great. So the median of this is 9 hours. Okay, so that's the middle. And then we can figure out how spread apart the middle 50% is by finding these quartiles. So Q1 is like, you look at the lower half. So we go like this. The lower half of the data is just 5788. After you take out the median, it's just 5788. That's the lower 25% of data. And so we just look in the middle. So what would Q1 be? We want the center of 7 and 8, 7.5, yeah. And then for the upper 75%, 9, 10, 11, 12, it would be 10.5, yeah. And so the range of the middle 50% of data is, we just subtract these numbers, Q3 minus Q1. So you basically go 10.5 minus 7.5, and so 3. So the middle 50% of data is spread out by about 3 hours. And then we can figure out if there are really extreme values using this formula. So if anything is less than Q1 minus 1.5 times 3, it's called an outlier. And if anything is greater than Q3 plus 1.5 interquartile range, then it's an outlier. So Q1 was 7.5. We just kind of plug it in this formula. Minus 1.5 times 3. So we get 3 there, right? So anything less than 3 hours, did anyone sleep less than 3 hours? So that would, if there were, that would be bad. If there were, they would be an outlier. Maybe one of you did. And then on the upper end, if we take the third quartile, which is 10.5, and we add 1.5 times the interquartile range, you get 15. So anything greater than 15 hours of sleep, wouldn't that be nice, is also an outlier. And then the mode is what happens the most often. So in that list, is there a number that occurs the most often? Like, what's the most frequent? So this is actually called bimodal, and you can also have trimodal. It's bimodal, so it's 8 and 9 would be the mode. 8 and 9 for this one.